In section 2.5, we're going to prove relationships between segments. So, we're going to introduce this word, theorem. It is a statement that can be proven. The good news is, once you prove it, you can then use the theorem as a reason in later proofs. So, we have some theorems, and these are the congruence of segments. All right, so again, congruence is going to be reflexive, symmetric, and transitive. All right, so for any segment AB, then segment AB is congruent to itself. Symmetric, all right, if I have segments AB and CD, then as long as AB is congruent to segment CD, then I can write that in the other order. And if I have three segments, and the first two are congruent to each other, and the second and the third are congruent, then I can use the transitive property of congruence to say that the first is congruent to the third. All right, so you're going to want to call these properties of congruence, all right? And so you're going to want to make sure you're very clear whether you're talking about congruence or equality when you're using your reasons in a proof, okay? So we're going to look at this first one. We're going to give a proof of the symmetric property of congruence. All right, so we're going to be given that segment AB is congruent to segment CD. All right, so my reason for statement 1 is given. All right, and then to say that the length of AB equals the length of CD, that is the definition of congruence. All right, in statement 3, I reverse the order of that, so that is the symmetric property of equality. All right, and then in statement 4, all right, I have then used my definition of congruence to go from saying that two segments have equal length to saying that they are congruent. All right, so that is the definition of congruence. Now we've proved it, so we can use it. So in our next proof, my first statement says that LK, the length of segment LK, equals 5, and the length of segment JK equals 5. And so those are given. All right, so my reason for statement 1 is just given. All right, and I'm going to use that if LK equals JK, all right, this is actually the transitive property of equality because we're talking about lengths, okay, and those are equal signs, not congruent symbols. So this is the transitive property of equality. Okay, remember you could write that as POE. All right, and then statement 3, that segment LK is congruent to segment JK, is using our definition of congruence to go from the length of two segments to saying that they are congruent because it is the same length. And then now in statement 4, now we have used the symmetric property of congruence that we just proved above. And then our reason for statement 5 is that if I went from JK is congruent to both LK and JL, then they must be congruent to each other, and that would be the transitive property of congruence. One more example. So we are given that M is the midpoint of segment AB, and we are going to use the midpoint theorem from chapter 1 to make statement 2 that says that the two segments All right, when M is the midpoint, must be congruent. All right, and then statement 3, we're going to use the definition of congruence to say that the two lengths are equal. And then statement 4, I am taking AM, all right, the length of AM plus the length of MB, and I am saying it is equal to the total length. So I am adding segment, so this segment addition postulate. And then in statement 5, I am substituting in the value of MB from statement 3. And so I get statement 5, which I use substitution, all right, from step 3. In statement 6, all right, I've simply simplified. I've combined like terms. For 7, I have divided both sides by 2. So it is the division property. Okay, and since I'm working with an equation, it is the property of equality. And I know I spelled that wrong. And then statement 8, we go back again to statement 3, and I take the value for AM, and I substitute in, all right, MB, and so I also get that MB also equals 1/2 AB, and that is again because of substitution from step 3.